Hello boys and girls. Today we are going to be learning how to find the prime factorization of a given number. The first thing that I want to review before we actually get into prime factorization is the powers. You'll see why near the end of the lesson why this is so important. Just a quick review. If I have 2 times 2 times 2, a way that I can rewrite that, because I'm doing 2 times 2 times 2, is 2 to the third power. The large number is the number that you're multiplying, and the small number that you write up here is called the exponent. It's the power that you're multiplying it to. So 2 to the third power means 2 times 2 times 2. I want to do a note that it does not mean 2 times 3. It's a shortcut. 2 times 2 times 2, you can just write 2 to the third power. This is not much different than this, so that wouldn't be much of a shortcut. But this is very different than this. So when we're doing the ending, let's make sure that we're writing our powers correctly. Now that we've done that review, we're going to go ahead and go straight into prime factorization. Now the key word in here is prime. You can only end up with prime numbers in your answer. Therefore, would you have a 4 in your answer, or a 6, or a 9? None of those numbers will be in our answers for a prime factorization. You can only end up with 2, 3, 5, 7, 11. Usually it's going to be made up of a lot of 2s and 3s. If you get an answer with a 4, 6, 8, 9, or 10, or any other number, you know that you've made a mistake somewhere. So let's go through the steps. Let's start with a nice easy one. 24. So the first thing you do is you break your number into 2 of its factor pairs. So I'm going to do the example of 6 and 4. Notice we're not adding, we're multiplying. 6 times 4 is 24. Then I continue to break down those numbers. Be careful, we're multiplying, not adding. Not 3 and 3, 2 times 3, and 4 I would break into 2 and 2. Now I check, am I at prime numbers? 2 is prime, 3 is prime, 2 is prime, and 2 is prime. I circle all the prime numbers. And then I group the like numbers. I have 2 times 2 times 2 times 3. I circled 1, 2, 3, 4 numbers, and I wrote 1, 2, 3, 4 numbers. Then I take a second here to check. What is 2 times 2? 4. Times another 2, 8. Times 3, 24, which means I've done it correctly because my number that I started with was 24, and my multiplication down here is 24. But we want to do one more step to simplify it even more. Think back to the powers that I started with. We have 2 times 2 times 2, which gives me 2 to the third power. We cannot forget that times 3 times 3. Therefore, my prime factorization of 24 is 2 to the third power times 3. Now, quick note, it doesn't matter what 2 numbers you break it into. I could have broken it into 2 and 12. I could have broken it into 3 and 8. I would still end up with this same answer. I'm going to go a little bit more quickly through another example. Let's try 36. I'm going to break that into 2 and 18. I see a prime number. I'm going to circle it right away so that I don't forget. 18 can break into 2 and 9. I see a prime number. I'm going to circle it right away so I don't forget. Is 9 a prime number? 9 is not a prime number because you can break it into 3 and 3. And right there I see some some prime numbers, so I'm going to circle them. Now, it doesn't matter if your prime number is near the top. If you have a prime number in your factor tree, you include it. So I'm going to put them, group the like numbers, 2 times 2 times 3 times 3. I check my tree to make sure I circled all my prime factors. I did. And I now check to make sure I have the same amount of numbers circled as in my setup down here. 1, 2, 3, 4. 1, 2, 3, 4. Now I'm going to use my powers to set it up in a little bit more succinct way. 2 times 2 becomes 2 to the second power times 3 times 3, 3 to the second power. Now I skipped a little step, so I'm going to go back and check to make sure what I did makes sense. I'm looking for 36. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. I'm constantly checking to make sure that my work is right. And this is how we find the prime factorization of any